All right. So let me go ahead and share my screen. Um, okay, so this is the current state of the draft PR that Nicholas is working on. And I believe let's see, he added the key management lifecycle to certificates. Is that correct?
Yeah.
Because we had it in keys, I believe, but not in certificates.
And then I
Oh,
think
but
there were
that's not what this.
some, yeah, I think this commit is basically also adding some descriptions, right? And I think before it was talking about some of the descriptions were a bit maybe misleading. Like they were
Mm,
talking about the protocol, but actually it's component, right? Or yeah, it's not really a protocol. I think these were just some leftovers from copying the same idea from protocols, right? Where there's also this related crypto assets um, thing.
right.
Mhm.
Okay, so we got a reason. That's fine. Um, all right, okay. Sure, reason. Extension name, right? Okay, the name of these. Okay, well, that's a typo.
Yeah.
Is this really the description? This should be the value, right?
Description of the. Yeah. Looks like it should be the value, right? Yeah, I think the idea is there that you have this standard or certificate extensions, but then you can have more, right?
Right.
Capture
Yep.
them, so yeah, makes sense to have name and value. Yeah, which or maybe it could be called certificate instead of component because that's about certificates.
It's more of a question than anything else. Related cryptographic assets, component. Why didn't? Oh, I see. Okay.
Isn't the, I mean, that's a, it's defined, right, in definitions related cryptographic assets. Might be that's actually a bomb ref.
Yeah, that's why I put that other comment up there. I mean, I don't want to be less descriptive. if we actually need the bomb refs there, which I can't remember if we do or not, but if we actually do, then we should keep that in there. So this is in multiple places, 50 related cryptographic assets, related cryptographic assets, related cryptographic assets.
I think that's in each of the
Yeah.
asset types, right? Each of them have one, or most of them.
Yeah. Yeah, that's what it looks like. Algorithm reference to cryptographic asset. Okay. I think this one's looking good though, for the most part. Does he have anything else open? Is this the only PR open?
I think it's
Yeah.
part of this bigger PR, right? This one, yeah. And that's just one commit of it. It's not the full PR.
Okay. Um, oh wow. This is very different. I don't know what's going on here. There's like 200 and some odd changes.
Mm.
So I'm not sure what's going on. 272 files.
We also tried to see the changes today, but I think it's maybe some merge because of
Yeah,
a merger, so it shows more than the actual changes.
right.
Yeah.
Yeah, okay. All right, well, let him know that because obviously I can't check in something with that many changes. Um, okay. Did we want to move over to talking about algorithm family names?
Yeah. I think would be good maybe to talk about that. Um, yeah. I think that kind of the idea was so far to kind of to focus on algorithm families, right?
Mm-hmm.
Rather than let's say the full um, subcategories of each algorithm, just to reduce some yeah, was a blow up of a list that we have, right? That we will end up
Yeah.
having. And then I think we had as kind of a template, we have some sources, right, of algorithms available,
Mm-hmm.
for example, from the CBOM kit, right, from IBM CBOM kit. And also SPDX has a list of algorithm names, right? And yeah, just so I mean, one approach would be okay to take them, right, and then to think about what else could be added, right? Um, yeah, I mean, just to me, if I look at that, it's kind of I mean, the question I have then is kind of what was the approach behind that, right? Do we just want to do an exhaustive collection of all algorithms, right, that we can think of, or what's the kind of how do we approach that? And
Yeah, I mean, I would like to create a fairly big enumeration of the algorithm families.
yeah,
And then also allow for just extensibility. So if you don't know the ID of something, you can just enter the algorithm name.
Yeah.
So like, that'll cover cases where, we are not inclusive of all, or it'll cover cases where there's some legacy or some brand new thing that didn't exist previously.
Mm.
So I think we can do that. We have existing patterns in the spec that do that for other things. Um,
Yeah. I mean, that's also one point, right? We should add, let's say, the not only state-of-the-art algorithms, right? But also, let's say, legacy ones that should not be used anymore, right?
yeah.
Um, that's just, yeah, to be able to capture that if there is a tooling identifying such algorithms. So we would have to go beyond what is, let's say, current standards, right?
Hmm.
That's
Yeah.
one thing. Yeah. And yeah, I was just thinking about bit about yeah, how can we determine the priority of the algorithms that we add there? And I think the a way we could do that is to actually start again with let's say most common use cases of cryptographic uses. And yeah, what is maybe the most frequent use case for cryptography? It's TLS, right?
Sure.
So we can have a, yeah, so we should probably have a look at just go through the standard that defines TLS, and not only TLS 1.3, right, which is the up-to-date ones, but also 1.2, 1.1, 1.0, SSL version 3, and so on. And if we look at all those RFCs that define them, we will be able to distill a number of algorithms or algorithm families, right, in these standards. And then, right, so we could think about some of these use cases like TLS, right? We also have in the protocol section, we have IPsec, so we can do the same thing for IPsec. And then SSH probably, and maybe some other use cases, and do the same exercise there. And so, and additionally, so what we have, for example, in the CBOM kit, the algorithms there, I think they were more created from the view of we look at popular crypto libraries and see what they support, right?
Mhm.
What algorithms they support, and then there is a list from there. So that's, I think, another use case, right? What is
Yeah.
currently supported by cryptographic libraries. So, but then again, that only looking at it from that angle, we might miss some, right? Because current OpenSSL or current Bouncy Castle doesn't support the outdated and deprecated algorithms anymore, right? But we
Right.
might still want to capture them.
Right.
So I think that could be a way to just um, define a priority on what algorithms we should add to this list first, right? And then if we do that, after that, we can actually, yeah, do more if we like, right? Or if we can think of, yeah, more use cases
So
have there.
yeah. So one of the things that we were discussing previously was what level of granularity and is there any consistency that we can apply or not.
Yeah,
I think we concluded based on a number of examples that we are not able to have a consistent definition of what constitutes an algorithm family. So, for example, AES, I think that's very simple, right? AES would be the algorithm family. And then, of course, you got all the modes and everything else. Um, SHA-1, 2, and 3, that's also fairly simple. Um, but other things like DES and triple DES, for example, um,
yeah,
I don't think they should be the same family. Um,
yeah, exactly. So there is some question around that as well. But I think what we could maybe probably do is, I mean, my question was, is it actually useful to have algorithm families in there? And I think probably yes. Just, I mean, one aspect is that an algorithm family is usually standardized by a certain standard, right?
Mm,
So
yeah.
if we look at the new like ML DSA, the new quantum safe signature
Mhm,
is standardized by FIPS 204, and AES is standardized by another FIPS standard, FIPS 197 or something like that.
mhm, yeah.
And I mean, yeah, don't have an exhaustive list in my head, but I think also like triple DES is standardized by a FIPS standard, right?
Right.
So we could say, okay, we try to map algorithm families to the actual standard that defines it, and
Mhm,
that would
yeah.
resolve kind of our question, is it a family or not? Then we
Okay.
can also kind of say, okay, why we did it like that? It's because it's in this standard.
Right. Which that is a good point because one of the things that I would like to do for algorithm families is I don't want to. So, one, I think it'll be externalized, kind of like what we do with the SPDX license ID schema. It's basically a sub schema. So we can bump that whenever we want without bumping the CycloneDX spec itself. So we'll probably do something with algorithm
Yeah.
families. Um, but other than just providing a list of enumerations, I would like to provide some other details, such as where you can find the standard. What other types of details should we think about including in that?
Yeah. Um, yeah, I mean, the standard, right, I think is one thing. And there, and sometimes an algorithm is covered by more than a single standard, right? So it might be actually can list several standards if they describe the same algorithm.
Right.
Um, and right, I think that that will be useful because often I think if the use case is to have to use that to check the inventory in the CBOM against some policies, right? So the policies will probably or might say, you should follow this and this standard, right?
Right.
Yes, it needs to be FIPS 140-3 or something like that, and that
Right.
will provide that would be helpful for that, I believe. And yeah, I mean, then the other thing is, we said we don't want to have that as an exhaustive list, but still, the algorithm variant or the algorithm the mode of the algorithm, I think would be useful to capture there as well. Um, and there again, I think the question is also, I think last time Niklas had the idea to define a regex for them. So you can kind of saying, okay,
Oh, right.
we have AES, right? But then, okay, it's AES, and then comes the mode, so it's CBC or ECB, and then it's the key length. Um, I think that's a possibility, and then it's the question then is how do we want to come up with that pattern? And what we could do there, I think, is if we take as a basis the standards, right?
Hmm.
They will list the different variants, right, that they standardize. And
Yeah.
we can try to just refer to that standard and say, in there, it's written like that, and that's the pattern you should follow, right? And try to create the regex or maybe just point to that standard. Not sure what's the best approach there, but just to avoid that we have a very large list of variants that we have to add to this the schema itself or to the list.
Okay.
And then something else, but we already have that in the 1.6 schema is the primitive.
Mm,
Um, So it's signature or key exchange or block cipher.
Yeah.
Yeah, I don't know. Maybe this could be bundled in an I don't know an object. These
Yeah,
different.
exactly. Okay.
I mean, they are this. Yeah, I mean, then it would be kind of. Yeah, you have useful information. You have the algorithm family, so you can link that to the standard. You would know what exact variant it is, following a pattern described in the standard, and you could resolve some ambiguity, like RSA is either a signature or an
Hmm.
encryption scheme, and that
Right.
would be resolved by the primitive. Um, right. And then something that I'm not sure if we want, or I mean, we already have that in the schema. And I saw also in the SPDX schema, they have this security strength in there for algorithms.
Mm.
Mm,
Yeah, that's going to change over time, though. I mean,
it could,
wouldn't it?
yeah.
Yeah.
It could, yeah.
I don't even know what that numeric. I mean, because that was taken from some tool, the OSS something or other. And I don't know what criteria they used for that value anyway. Um,
Yeah. I mean, it's a bit, but I think what they did was, I'm not sure, I think in AES it just says it's 256 security strength, which is
right.
just the case in AES 256, but AES 128 has 128-bit security strength.
Okay, so you're talking about that. I thought you were talking about the classical how in CBOM we've got like the quantum and the classical NIST,
Yeah.
or I'm sorry, the NIST one for quantum, and then the classical strength, I think it is.
Mhm.
Um, okay, so you're talking about more of the length or whatnot. Yeah,
Yeah, but again, I mean, this classical security strength doesn't say anything about if it is quantum safe.
right, exactly.
Um, yeah.
Okay.
I think NIST recently published a special publication. I have to search for it, where they define some things about security strengths
Hmm.
for algorithms. Maybe that could be used as a reference.
Okay.
Yeah.
Okay, so I've got the algorithm family name, the standards plural, possibly, that describe that family. The variant and mode may be useful. Define the naming convention for the algorithm family via regex, and then point that to the reference in the standard. The primitive used, the available lengths or strengths, and then a spike to investigate this NIST SP document on security strengths.
Yeah.
Okay. I think that makes sense.
Yeah, I think that would be, we probably add some Yeah, no, like algorithm family alone, right, might be not enough, right, to bring something to get some useful information about it. But yeah, with together with the standard and the variant, maybe security strength. Not sure if that makes sense at the end. Yeah.
Yeah.
That's,
Yeah.
yes.
Um,
And then yes, I mean, I would suggest then I mean, there'll be some work, right, to approach it from, let's say, most popular uses of cryptography, right, to come up with this list of algorithms so that yeah, I think it'd also be good to be able to describe what's the approach, right? How did we come up with this list of algorithms? So by saying, okay, these were the priorities, the most popular crypto libraries, the most popular protocols, and yeah,
yeah.
plot their previous versions of the protocols to also come up with deprecated and legacy algorithms.
Hmm.
Yeah.
Yeah. Yeah. Um, I do think there are use cases for like the available strengths, for example. Um, just hypothetically, I mean, AES 128, for example, if you're using that, um, obviously there should be a plan to at least move to 256. Um, but if AES didn't support 256, that could lead to a potential decision if you are on the consuming end of a C bomb that actually used that algorithm and there was no path forward, right?
Yeah. Yeah.
So I think including that, if we can get it, I think would be useful. Keep in mind that we're going to have to research all this stuff too. Because right now the CBOM kit um, has the algorithm names, um, but does it define all these other things? I don't think so.
Mm.
Um, let's see.
Yeah, I think it's difficult to say if that's all right or if it's not all. If we don't look at it from, let's say, I don't know, top down, from the algorithms that actually use the algorithm use those. Um, yeah.
Yeah. Okay. Let me try to, between now and our next call, I will come up with a proposal for a subschema to capture this specific information.
Mm-hmm. Yeah.
And then on our next call, we can talk about it and see, is this what we want or not?
Yeah.
Um,
Yeah.
and of course, we can do that offline as well. But I think it'll give us something to discuss next time around.
Mm-hmm.
And then I think this is the harder of the two, the curves, the list of curves, that is basically just going to be an enumeration. However, and we should probably define like where you can find the curves and stuff like that, the definition of those curves, whether it's a research paper or standard, etc. Um, there's not nearly as much data that we need to capture, but the list is much longer.
Yeah. And there is already some kind of good reference, right, for
Yeah,
this
yeah, we
list
have
of.
a good starting point, which
Yeah.
is amazing.
Yeah.
So yeah,
Yeah. And yeah, what I would want to try for maybe the next call is to just go maybe through one example. Let's say TLS, one version of TLS. Try
yeah.
to do that exercise, reading through the standard and try to identify the algorithm and algorithm families, reference that to standards, and then come up with algorithm variants from there.
Mm-hmm.
to just get a
Okay.
feeling how, if that's feasible, right, to do, and
Right.
how much work this will probably be,
Right.
if we want to extend that to more use cases.
Okay. All right. Um, Question for you. Now the IBM, I'm actually looking at it, it's the Sonar Cube, Sonar Cryptography repo. That's kind of where all the algorithm stuff is
Yeah.
kind of defined in there. This to me, unless I'm completely missing something, I mean, I don't know what some of these algorithms are, so maybe I'm misspeaking, but this appears to be, um, things that typically are used to, you know, encrypt secrets, encrypt protocols, transit, um, signing, those hashing, those types of basic things. Are there any like say for example, like wireless, or satellite or anything that's like not over the wire or that sort of thing that is typically used in other industries that maybe we're not capturing?
Yeah, I mean, definitely yes.
Hmm.
Um,
I just don't know what they are.
yeah, yeah. Think like if you like in telco, like 3G or even
Hmm.
2G networks, they use some, yeah, more a bit uncommon algorithms. Um, and then, yeah, that would also be some use cases, right, to go over them, right, to see what, come up with a list from there. Um, yeah, and these are things that are usually not so available. I mean, it might be some algorithms not so available in, let's say, mainstream crypto libraries, right? But more like
Right.
special purpose for that. Um, yeah.
Yeah. Yeah. Um, but I think it's important to capture at least some of the more well-known ones that
Mm,
are very industry specific. Um, I just don't know enough to know what they are.
mm.
Um,
And
I think I
wireless
know. What's that?
Wi-Fi also uses some custom algorithms like
Right.
I mean there was web or WPA.
Right.
Um,
Exactly.
they
Yep.
did not use just AES. Also using some weak algorithms actually that can just be broken.
Yep.
Um,
Yep. I think every researcher and or offensive security person at least one time in their life have done some kind of war driving.
yeah, yeah, yeah. We was like at university. We even had like a lecture just going through those weak crypto primitives.
Yeah. Yeah.
See how easy it
Uh,
is to break them.
exactly. Okay. All right. Is there anything else that we wanted to try to achieve for today?
I think that I mean, for me, that's okay. I mean, just yeah, just wanted to talk about that as yeah, some different aspects of these algorithm names, and if also to get yeah, feedback from you if you think that makes sense to um, try to collect those algorithm names with an approach like that, right?
Right.
And then just starting with the most popular yeah protocols, and then see if it works like that. And then maybe as a next step, we can also talk about some more, yeah, yeah, industry specific use cases um, to,
Okay.
yeah, find out what, or to be able to capture what is used there.
Yep.
Yeah.
Yep. Okay. Well, good. We can go ahead and end, but I'm gonna use this time. I got the next 15 minutes or so. I'm actually going to start on this now that it's kind of all fresh in my head. See if I can start working on defining what this scheme is going to look like. And well, I mean, it's going to take a little bit of work because it needs multiple use cases, both for enumerations as well as for definitions of things. So it's not exactly, you know, simple. However, it should be doable. And then if I have time, I'm going to go through that list of algorithms in the Sonar cryptography repo that IBM has and start populating it. Of course, I won't be able to populate all the fields because we're going to have to do some research here. But I can at least start populating it just to kind of give an example of, hey, this is what it could theoretically look like. So we have both of those things before the next time we meet. Sound good?
Yeah, sounds good. And I
Okay.
will also try to start looking at TLS, maybe 1.3, and
Okay.
come up with
Awesome. Yeah, that'll be really
algorithm.
useful exercise next week.
Yeah.
Okay.
All
Cool,
right.
Basil. I'll talk to you soon. Have a great day.
Bye.